A very good evening to one and all present here. It gives me immense pleasure to welcome you all to this AICT ATAL Faculty Development Program on Smart Device-Driven Energy Solutions for a Sustainable and Climate-Resilient India, organized by Department of EEE and ECE, St. Peter's Institute of Higher Education and Research. We are deeply honored to have an enthusiastic group of participants joining us from diverse institutions and disciplines across the country. I take this opportunity to welcome our esteemed resource persons who will be imparting valuable insights, hands on experiences, and industry perspectives throughout the sessions. A special welcome to our respected Registrar Dr. L. Mahesh Kumar, whose constant support and guidance have been instrumental in organizing this FDP. I wholeheartedly thank AECT and ATAL Academy for providing us this wonderful opportunity to conduct such an impactful program. Dear participants, your active engagement and willingness to learn will make this FGP a grand success. Over the upcoming sessions, we hope you will gain new ideas, enhance your teaching and research capabilities, and contribute meaningfully to the academic community and society at large. Once again, I warmly welcome each one of you and wish you all a productive and enriching learning experience. Thank you. Honor to welcome our distinguished speaker, Dr. T. Sudhakar Babu, Senior Member of IEEE, who is currently serving as the Associate Director R&D and Associate Professor in the Department of Electrical and Electronics Engineering at Chaitanya Bharati Institute of Technology, Hyderabad. Dr. Sudhakar Babu holds an MTech in Power Electronics and Industrial Drives from Anna University, Chennai, and a PhD from VIT University, Vellore. He has also completed his postdoctoral research fellowship from the Department of Electrical Power Engineering, University Tenaga Nasional, Malaysia. With a remarkable academic and research career, Dr. Sudhakar Babu has published over 250 research articles in various renowned international journals. His excellence in research has earned him several prestigious recognitions, including the IEI Young Engineer Award and the Vice Chancellor's Research Excellence Award. Notably, he has been listed among the top 2% of researchers in the world in the area of electrical and electronics engineering, power, and energy, as reported by Elsewhere and Stanford University. Dr. Sudhakar Babu also serves as an editorial board member and reviewer for several reputed international journals, including IEEE Access, IET, Elsewhere, and Taylor and Francis publications. Sir, we are truly privileged to have you with us today. On behalf of the organizing team and all participants of the ATAL FDP, I extend a very warm welcome to you and look forward to your insightful session. Thank you, sir, for accepting our invitation and for taking the time to share your expertise with us. Over to you, sir.
Is it visible, ma'am? Can you please confirm?
Yes, sir.
Yeah, okay.
It's visible.
Okay. Good evening to one and all. So I'm Sudhakar Babu. So I'm working as Associate Director in the Chaitanya Bharati Institute of Technology, Hyderabad. So I'm happy to be here with you all to share my views in the field of solar and other renewable energy resources as part of our ATAL FDP Smart Devices Driven Energy Solutions for a Sustainable and Climate Resilient India, organized by the St. Peter's Institute of Higher Education and Research. So, I would like to thank the management and members for inviting me to this FDP and to share my knowledge with all the participants. And as part of this, today I will be discussing on the topic called Challenges in Renewable Energy Resources and Across to the PV System. So all of you knows that. Let's move into the further details, all of you know that everybody is moving into the renewable energy sector because of the various limitations what we are facing with respect to the conventional energy resources and global warming effect and other pollution and other things. Moreover, these conventional energy resources may also get depleted in the future years, thereby to protect our environment and along with our society. It's a time to focus more towards the renewable energy resources. And moreover, to achieve our goals to work in the field of renewable energy resources, the governments of India and all other governments of the countries also initiated various policies, schemes, and other benefits to the customers and to utilizers whoever having the higher percentage of renewable energy sector contribution. In this regard, let us look into that what are the challenges we are facing and how much power we are developing in the present scenario and how these power are going to utilize in the day by day. So this is a small statistics which I have taken for the presentation here. According to the 2025 IEA Indian International Energy Board of Renewable Energy, statistic shows that the complete global renewable energy sector surged by the 10 percentage in the 2024 comparing to the previous years. This shows a rapid growth in the field of renewable energy sector and how the world is moving in development of the renewable energy sector in the present scenario. And moreover, while we are moving into this renewable energy sector, the major contributors of the renewable energy sectors are mainly two things that are solar and wind are dominating. So that we can observe here. Here, the solar and wind are mainly dominating in renewable energy sector. And moreover, as we are able to know that the renewable energy sector is dominating comparing to the conventional one, and moreover, if we observe that there will be a certain amount of challenges whichever we develop and we focus or whichever we are trying to lies in the fields. Thereby, what are those difficulties we have it and moreover challenges? So all of you know that the power production is not only a thing to have a complete utilization. After the power production, we need to provide continuous supply to the customers and to the industrial sector for the effective load usage. Then only we can say that even though we have a plenty amount of renewable energy sector development and growth, without proper utilization, we can't say that the 100 percentage of renewable energy is comes into the utilization. Thereby, in this regard, grid integration is one of the major challenge what we will be facing. That indicates that, as we know, the renewable energy sector is maximum the distributed energy sector. So, what do you mean by the distributed energy sector? A small amount of the PV plants and wind plants and some other renewable energy plants can also be installed by the owners and the customers in the field of a domestic and commercialization purpose. Thereby, as the number of the power producers are increasing in the field, the integration of all those things are a greater challenge. Thereby, the grid synchronization and grid integration is a major challenge what we can assume in this scenario. Thereby, to achieve and to overcome these things, here we are going to mainly focus in the field of a power system studies or power system analysis are highly recommended to analyze the grid conditions and grid behavior to avoid the blackout conditions which we have seen few years back even in India and the foreign countries. Thereby, it's a time to focus the effective utilization, moreover, to avoid the challenges whatever we are facing. In addition to these grid challenges, here we have some other challenges. What we are facing here is a financing and affordability pressures. As we know that the increasing of renewable energy sector here is a mainly the solar PV system. As we know that the solar PV system is initiated from the last few decades. Moreover, the technology of a PV is having a combination of various material things and also the combination of all those things. Thereby, the PV technology yet to get growth to have a reduction in the installation process. So this is one of the major thing what we need to focus. We not only to encourage the people towards the utilization of renewable energy resources, it's a time to encourage the people who can develop or who can build the renewable energy sector, the concepts and also the necessary components which will produce the power sector. That is one of the major challenging. And other than that, the development struggles, that is also a part of the manufacturing process related things. And after that, as we mentioned that policy and uncertainty. To understand and to utilize the more amount of power, we need to have a effective policies in terms of a mobilization, utilization, and industrialization. Whenever we have a complete encouragement policies, then only everybody will look into that. So these are the generalized sector where we can focus on what are the major challenges we are facing in terms of the financially or establishment of the products and the companies and other things. Now, as we are a electrical engineer and we have a complete a good amount of background in the field of electrical related systems, what we can take part to overcome the challenges of these renewable energy resources. To understand those particular things, here the my presentation will focus on the following concepts here. So as electrical engineering students, we need to focus mainly in the following things, that is the introduction to the PV system, what components are there, what will be the cost of the complete system, and after that the type of a PV system. If we observe that the most of the domestic distributed energy sector is growing these days, thereby how they are going to utilize the complete generated amount of power, are they using their complete purpose, or they are exporting the power, or they are going for the backup, all those things we'll be discussing in case of a PV systems. And after that, so far we understood that the installation of the PV system is done and utilization is done. After that, whatever the PV system we have established or installed, are we able to generate a good amount of power or effective amount of power or not? That is one of the major challenge. We need to check it out. If we are not able to get a maximum amount of power, what are the reasons? So in regarding to that, the partial shading is one of the major scenario what we used to observe. This is a greater amount of part of the power going to wastage from the power generation. In addition to that, how we can avoid this partial shading effect in case of a series condition, parallel condition, what are the different methods are there? So these concepts I will be having a more focus in today's session. Thereby, at the end of the session, you are able to understand what are the various challenges we are facing in the field of renewable energy sector. Moreover, as an electrical engineering student, in which scenario we can focus and what portion of contribution we can do, that you will have a good knowledge. So with that belief, let us move to the further. So comes to the solar PV system. As we know that it has a major components and also the cost of the system is also higher. So here if we observe that for installation of the solar PV plants, what are the major contributions regarding to the cost? If we observe that, the first thing is that the installation of the PV plants, and after that, the major contribution is the battery energy storage system. As we know that whatever the power we are producing, we can't utilize in the morning hours. Moreover, the solar PV is a continuous intermittent power generating system. Thereby, we can't expect the same amount of power production in the entire day. Thereby, it's a necessary to have a storage capacity for effective utilization and to avoid the connectivity issues. Thereby, the energy storage system is also a major cost contributor in this particular system. And after that, for the effective safety and secure purpose, we need to have a proper schemes that are also known as a safety precautions and precautionary circuits and the relays and other things. So these are the major contributors what we used to observe in case of a solar PV system. And here comes to the next slide here. What are the different type of PV systems are there? The first system comes from the right to the left. The first one is standalone solar PV system. So the standalone solar PV system indicates that whatever the power we are producing by installation of the solar PV system completely utilized by the customer and for their own purpose. So they will not export any amount of power to the other things. That is known as a standalone solar PV system. Here we can observe that. And after that, the grid connect with a battery backup system. So it indicates that the complete system is connected to the grid. Whatever the power we are generating, that particular power we will be utilizing for our own purpose. And in addition to that, the power will also stored as a backup by using of a battery, and excess power will also be sending to the grid. Thereby, here we can also earn the money for the power production whichever we are doing. So this is the one maximum cases will be implementing by the customer. So this is one of the major scenario and second type of a PV system. Our next one is a grid connected PV system, and this is one of the another type of a scheme. In this one, without battery energy storage capacity, whatever the power is producing by the PV system completely exporting to the grid after our utilization without any storage capacity. Thereby, the major contributor of the battery cost can be overcome in this particular scenario. This is the third type of a system what we have. So we can understand that from this slide how many type of a PV systems are there and what will be its main usage and which system can be focused for our effective utilization. So these are the major things. And here comes to the partial shading. So what do you mean by the partial shading here? So as of now, we have seen that the solar PV panels have been installed and we are producing a power and we are exporting power to the grid and all other things. And before exporting the power or before looking into the power estimation, we need to check it out. Are we producing the estimated amount of power or not? That is a major thing we need to cross check by our own. If we observe on all these things, certain cases will not be able to produce the maximum power. Why? Because if we observe the slides over here, here in the first scenario, these PV plants are established or installed near to the trees. Thereby, the part of trees shadow is falling on these particular locations. Thereby, what will happen because of this entire PV panel may not be receive equal amount of irradiation. Whatever the panel exposed to the sunlight will only generate the power, the other portion will not. Thereby, the complete PV module may not produce equal amount of power. Because of this, power generating capacity of a PV system greatly reduces. So this particular scenario is known as a partial shading. So this may occur because of the tree shadows or nearby building shadows or passing of the clouds and some other scenarios, and moreover the dust whichever is falling on the PV modules. Thereby the cleaning of PV modules also we need to give a higher priority for effective amount of power generation. So these are the partial shading. So because of this partial shading, what will happen that we'll see in our next slide. So I believe you are able to understand the concept of the partial shading, what it is. Yes, so this is a partial shading scenario occurring because of the cloud passes. So this is a huge land where the PV plant is installed for the commercial purpose. So nearby these locations, we don't have any larger buildings, lengthy buildings, and also the trees. Thereby, even though the shade is occurring because of the clouds on the sky. Because of this also, the PV plants are completely shaded. They are not receiving the irradiation here. That is one of the major challenging over here. This is the one receiving full amount of irradiation. Here also receiving full amount of irradiation. So this scenario is called as a partial shading. Now, how we can overcome this partial shading? And because of this partial shading, what will happen? That we can observe in this particular scenario. As we know that the solar PV is nothing but a combination of a PN junction diode. So all of you know that the characteristics of a PN junction diode is a non-linear device. So because of that, what will happen? The characteristics of a PV system will not be constant for a particular duration of time. We can't estimate it. Thereby, because of the nonlinear property, if we observe that the value of voltage is increasing, the power value will also be increases up to certain period of time. And after that, further the voltage is increasing, the value of power is comes down. So this property is known as a nonlinear property. Thereby, from this curve, what we can observe that at particular instant of time of a solar PV plant, only at particular portion we are able to get the maximum power. After this point or later this point, the power produced by the system will be less. That is one of the major challenge what we have in case of a solar PV system. So for understanding this particular concept, here I have considered a 4 module solar PV array. And whenever these all PV modules are receiving good amount of irradiation, the power produced by the system will be indicates this blue color line. So it means that full irradiation is receiving by the system, and thereby the maximum amount power is also producing. Comes to the second case, what is happening here? The partial shading. We have seen that. What do you mean by the partial shading? Now let us see what will be the effect of a partial shading. Now in this 4 PV module scenario, this particular portion is completely shaded. Thereby, because of this, what will happen? The current producing capacity of this particular system goes down, and moreover these panels are connected in series. So what will happen because of this series connection system? As we know that in case of a series connected system, same amount of current will be flowing, and whenever a kind of PV module is shaded, the current generating capacity is goes down. Thereby all PV modules may also generate the less amount of current, that is called as 0.5 ampere instead of a 1 ampere. So because of that, if we draw a curve here, that indicates the half of the power generation. So even though the complete modules, nearly 60 to 70% of the modules are receiving the full irradiation, power generating capacity is reduces to the less than 50 percentage. That is what a great challenge what we are facing. Thereby, it's a necessary to focus on this particular scenario. Thereby, how we can overcome this low power to the higher power, that is one of our major tasks in today's session. Thereby, to increase this power generation, will be connecting a bypass diode. So, what this bypass diode will be doing? Each and every PV module backside of that, a PN junction diode will be connected. Thereby, it will bypass the current whichever flowing here. Because of that bypassing property, a multiple peaks will occur like this. So each and every PV module will generate individual amount of power. So that curve we can observe here. The earlier, the full irradiation, the blue color one, and after that, without shading, without bypassing diode, this is the one. And after that, by using of a bypass diode, the curve will be like this. So comparing to the previous case, the current capacity is increased this much. So that's what we can observe in case of a usage of a bypass diode. Now let us see what is that bypass diode and how it will be connected and where all those things will be discussed in our slides. So here is the major thing, partial shading, and because of this partial shading, what is happening here, and it's a time to think on the efficiency. And here is a small example I have presented here by considering a 9 PV modules are connected in series, parallel, and series parallel combination. For our understanding, each and every PV module is receiving a full irradiation, thereby it has a capability of producing 1 ampere. That 1 ampere is giving as a maximum current I maximum. Thereby, since all these PV modules are connected in series, a same amount of current will be produced and the total voltage across the circuit will be 9 Vm. Thereby, the total power will be 9 Vm in case of a series connection. And now comes to the second case here. In case of a second case, the first two PV modules are shaded. These are the two PV modules shaded. Sorry. The shading irradiation is given here. The shaded PV module is receiving a 500 watts per meter square. It means that half of the irradiation. Thereby, because of this, what will happen? Instead of generating the full amount of current 1 ampere, these two PV modules will generate only zero point 0.5 ampere. Thereby, what will happen in this particular scenario? The complete system is connected in series. The same amount of whichever as per the property of a circuit, same amount of current will flow and which is the lowest value. And thereby, the voltage value across this particular system will be 9 Vm. The total power generating capacity is 4.5 Vm. So thereby what is happening among these 9 PV modules, even though only 2 PV modules are shaded, the complete 50 percentage of the power is getting reduced. So this is a huge percentage which we need to observe. And thereby, how we can improve this scenario? Our next connection scheme is represented as parallel connection system. In case of a parallel, the complete current will be additive and voltage will be the same. Thereby, the first scenario, all PV modules are generating 1 ampere current. Thereby, the total current production will be 9 Im. That is a maximum current. And voltage across the modules will be same. Thereby, 1 Vm. Here also the total power production is 9 Vmi. And comes to the shaded condition in case of a parallel. The first two PV modules are shaded similar to that. Thereby the current of this particular one will be 2 into 0.5 Im, and other PV modules are receiving a full irradiation, and moreover this system is connected in parallel That's why here the other PV modules current will be individually considered 8 im. The total current production will be here, if we observe that the 8 VMIM, that is the power generation. So comparing to previous scenario, we have improved the power generation. But even though the major limitation of a parallel system is that the entire power rating of a system will be less because the voltage capacity of this system is only 1 Vm. Thereby, the overall power production is increasing. This scheme may not be recommended. Thereby, the present scenario, all the PV modules are connected in series and parallel for the voltage, current, and power production. Similar to that, if we observe the current calculation, voltage, and power, the three total 9 PV modules, same PV modules are connected in series and parallel in case of a 3 row 3 column system. The power first scenario is 9 VMIM, and whenever the PV module is getting shaded, this particular PV module current is getting divided. Thereby, the total power production is comes to the 7 VMIM. Comparing to this case, the total power production is little bit less, but the voltage capacity is higher. That's what we can observe it. In the parallel scenario, the voltage capacity is only 1 Vm, but here the voltage capacity is increased to the 3 times. That's what we can observe it here. The PV modules are connected in a such a way that the series and parallel to increase the voltage and current. And now comes to the bypassing diode. What is this bypass diode? I have mentioned that individually each PV module will be connected by an additional diode at the module connectors. That's what here a single PN junction diode, a single diode is connected across the terminals of each module. Because of that, whatever the module is shaded, that particular module will be bypassed. Thereby, because of this bypassing property, the current production capacity will also be enhanced comparing to the shaded scenario, and the damage of PV modules will also be protected. So here, this diagram, we can observe that this is a normal scenario and this is a partial shading scenario. A bypass diode will be connected like this, and whenever the bypass diode is not there, this complete PV module, instead of generating 1 ampere, it will generate only 0.5 ampere. And this PV system is connected in series. This particular PV module will act as a load instead of a generator. Thereby, the temperature of this particular individual PV module may be increases largely. That effect is known as a hot spot, and that leads to the damage of the PV module because of the continuous flow of higher amount of current capacities. To overcome this, will be connecting a bypass diode. What will happen this bypass diode? Whenever this particular solar PV module is getting shaded, this particular PV module is get open circuited, and whatever the current should flow through this cell will be bypassed through this diode like this. Thereby, the no amount of current will flow through this PV module, and thereby heat generating in this particular one also reduced, and thereby the hot spot of the system will also be overcome. Thereby, in this particular scenario, two levels of different currents will be flowing. So here is the individual, the current calculation of a PV system is clearly described similar to the previous scenario. And here is a diagram. We can observe that the bypass diodes are connected here, and this is called as a blocking diode. What this blocking diode? The blocking diodes are helpful in avoiding the reversal flow of current from the load. So that's why these blocking diodes will be used. And now here is a slide which I have presented to understand the concept of how the current will be flowing in four different scenarios. The scenarios are given here. The first scenario is matched current at short circuit and mismatched current condition and matched current conditions at open circuit and mismatched current at open circuit. These current differences will come with the utilization of a bypass diode. So this is called as a bypass diode. Initially, these two bypass diodes will be in a reverse bias condition. And whenever the shade is occurred in this particular scenario, the bypass diode will comes into the forward bias condition. The bypass diode will be forward bias condition, thereby the current will flow through this bypass diode. Here you can observe that. So this is a diode current flowing here. This is a second scenario. On the third and fourth scenario, we can observe that the current flow will be takes place through this bypass diode. This is a electrical representation. This source and diode is a electrical symbol of a PV module. Since it produces a current, it will be represented as a current source and diode symbol will be given like this. This complete one is known as a electrical representation of a PV circuit, and this is a bypass diode. Now this bypass diode in the forward bias condition. So like this, the current flow will takes place through the bypass diode and circuit will be protected. And this is some samples which we have observed throughout our research, and the cases of hotspots occurred and the PV modules are physically damaged because of the high temperature scenarios. Here you can observe that because of the high temperature, the PV modules may get damaged like this. So to avoid these scenarios, even though this entire panel is large, because of a small disturbance like this, the entire PV capacity greatly reduces. So these are the possible scenarios where we have seen the occurrence of a partial shading condition and its effects. And now comes to the reduction. So we understood that the challenges are there and what are those challenges, and now it's a time to focus on overcoming those challenges. That's why to avoid this partial shading effect, these are the various techniques what we have. These techniques are categorized mainly into the two scenarios. The first one is a circuit strategies and the another one is a MPPT strategies. These circuit strategies are nothing but the connection of a bypass diode. Whichever we have seen, a bypass diode will be connected a backside of a PV module. Thereby, this some amount of current will be improved. And after that, the module integrated converter and micro inverter, multi input converter, dual input converter, PV equalizer. These are the different cases. These are the additional kind of a circuits will be connected to the PV modules for enhancing the power generation. But other than that, as a researchers, what we can do instead of directly adding some additional components comes to that. Here we are focusing on development of a MPPT techniques that are well-known techniques, maximum power extraction techniques. These maximum power extraction techniques will not only used for the solar PV system, will also be implemented for the wind energy storage scenarios as well. In that, the conventional MPPT techniques and soft computing techniques and other MPPT techniques are mainly classified into the three scenarios. The conventional one are the P and O technique we used to call perturb and observe and incremental conductance and hill climbing and other technical sizes. These MPPT conventional techniques are known as a standard step size technique. Because of these standard step size techniques, it will be operating with a limited capacity. As we know that the complete PV system power production is depending upon the environmental condition. The climatic conditions will not be same for the entire one day. and it will be changing from time to time, even minutes to minutes. In that particular scenario, because of these sudden changing irradiation levels, these conventional techniques may not be effective. Thereby, we are working on the soft computing techniques and other techniques. Now, let's look into that. What are the soft computing and other the circuitry based systems are there that we can observe it here. This is a first case. As I have mentioned, here I have considered the number of PV modules are connected like this. This is a bypass diode connection system. A bypass diodes are connected here. Now, because of the shading effect, two levels of current is producing. This is one of the circuitry based system what we have it. Our next one is a AC module or micro inverter, and each and every PV module is connected to the micro inverter. This micro inverter will enhance the power generation irrespective of the shade levels. Thereby, the overall power generating capacity will be increased. But what will be the main limitation of this? The connection of each inverter to the each module is a highly cost. Thereby, this method is not recommended because of the higher investment. Already the PV modules are having higher cost that should be overburdened in this particular scenario. And the next second thing is that module integrated converters. In this particular scenario, the DC-DC converters are connected to the individually, and it will be connected in series to the modules. Thereby, in this particular scenario, the cost of the system is reduced, and moreover, all the PV modules are connected in series. Thereby, the effective utilization will be takes place, and moreover, instead of connecting individual modules, all modules will be connected to a single converter system. Thereby, the converter capacity is also be reduced. This is another scheme what we have it. And multi-input DC to DC converter. And here is also the same thing, as we know that in this particular scenario, irrespective of the power production, the converter is having a multiple inputs. Each PV module is connected to the each input. The overall power generating capacity will be improved by using of this multi-input DC to DC converter. Here, a single converter will be used with a multiple inputs. That is one of the advantage what we have it. All these kind of circuits are thoroughly verified and also be presented in the prestigious various reputed journals. And now comes to the other systems what we have it. These are the bias voltage induction PV strings and PV equalizer and electrical reconfiguration. These are the techniques what we have focused in our research in by our research team. That's what presented here. Bypass voltage injection. So in this particular scenario, wherever the PV module is getting shaded, thereby the current and voltage capacity of that particular system will be becomes down. Thereby, by using of a additional booster circuits, the voltage will be maintained by the constant. Thereby, the overall the power production capacity of a system will be improved. That is a biased voltage injection in case of a PV strings. Our next one is called as a PV equalizer. This is also a extension of a previous system. Here what we are using, we are connecting a capacitor circuits across each PV module. Thereby, whenever this particular PV module voltage capacity is reduces, that will be stored by the voltage stored in case of a capacitor. Thereby, the overall voltage of this particular system will be maintained as a constant. This is type of technique is known as a PV equalizer. And this equalization procedure is implemented in a electrical array reconfiguration. So what do you mean by reconfiguration? This is also one of the biggest research topic what we can focus. The reconfiguration name itself says that the circuit is reconfigured based upon the different scenarios. That particular scenarios are the position of a PV module may be shifted from one place to the another one, and other than that, the connections of this particular PV module will be interchanged with a another one. Thereby, voltage of this particular one will be added to the another rows. Thereby, the row current of each PV system will be maintained as a unique. That is called as a electrical array reconfiguration. These are also some of the similar kind of a techniques what we have it: multi-inverter capacity system and integrated capacitor and current equalization. In the previous case, I have mentioned the voltage equalization, but here we can observe that the current equalization by using of a flyback converters. So these are the different scenarios. And now here is a voltage equalizer strategy which we have proposed by using of a combination of a capacitors, and the outcome of this particular work is published in the IEEE transactions, and the algorithm whichever we have calculated based upon the voltage levels are also detailedly presented. These are a comparative table which we have made for understanding the concept to the researchers by using of a bypass diode under different scenarios, and backtracking and mitigation strategies, what will be takes place, and also the limitation of a various methods by using of a different parameters. Moreover, we have compared the different type of a circuitry strategies by consideration of a more than 15 parameters. All these things are presented over here. So this is a comparative table what we can observe it. This is also a continuation of that. As we have mentioned, more than 15 parameters across the 15 different circuitry topologies we have compared it and presented. Here we can observe that this table is completely looks like a qualitative, but rather than this qualitative, we have also done experimentation and presented in the quantitative as well. So the quantitative is nothing but representing in terms of a values that shows a greater visibility in improving the power production of solar PV system comparing to the partial shading scenarios. And these are the some of the other connection schemes what we have it. We have seen series individually, and also the another one is called as a parallel, and the next scenario is series and parallel. Not only these three connections, we have some other connection schemes also called bridge link. So it indicates that in between PV modules will be having another tie. It will be connected like a big bridges. This is called as a bridge link. Because of this, the power production will be increased. And this is also a honeycomb. The name itself says that all the PV modules in a array will be connected like a honeycomb structures. That's what the name indicates that. And the another connection scheme, this is a widely used system called total cross tie. In this particular scenario, you can observe that the modules are connected in series parallel. In addition to that, all PV modules will also be have another tie like this, cross ties. These are called as a cross ties. So this is a TCT system. In this particular case, will not be having a connection here, only particular locations. But here, all you can observe that this is a one PV parallel system, and that parallel system is connected in series with other parallel system like that also we used to represent it. And now, as I have mentioned, a reconfiguration system, the name itself says that the PV modules are reconfigured based upon the power production. Now here, the position of a PV modules are given like this. One is representing the first row, first column, first row, second column, first row, third column, 2 1 2 2 2 3 2 3 like that. So now, based upon the shared levels, the connections between the PV modules will be interchanged. So this is called as a square dispersion position technique. Based upon a logics, the PV modules connections across PV modules will be interchanged like this. So now you can observe that this fourth PV module connection is shifted to here like this. So now you can observe that the position of a PV models are interchanged. So previously we have a 1 2 1 3. Now the position is interchanged. This interchanging will follow a certain procedure. The connection schemes are also shown here based upon the different logics will be following and implementing the connections of the systems. Thereby, the power production capacity will be also increased. So now you may get doubt that because of changing of a physically panels, it will be tough. That's why we are changing electrical reallocation as well. So these are the techniques have thoroughly verified and tested experimentally under different locations, different scenarios, different climatic conditions, and presented a produced complete results. So like this, the first scenario, the PV modules are vertically like this, 1, 2, 3 here, 1, 2, 3, 4, 5, 6 like this. Now the positions are electrical connections will be dispersed like this. You might have heard that the Sudoku puzzle. What Sudoku puzzle indicates the summation of rows. If you calculate with respect to the row wise, the column wise, vertically, horizontally, or in a cross section, everything should be comes in a same value. With that scenario principle as well, the shading of a PV module will be maintained constant. Whenever we have a constant shade, the power production will also be enhanced. That is in case of a electrical array reconfiguration. Here is the example we have presented fixed electrical array reconfiguration. In this one, the position of a PV modules were fixed and only the electrical connections of a system will be rearranged. That's what presented here. And this is a slide where we can observe another kind of a mitigation technique. Here, the required skill labors consumes lengthy words, one-time arrangement, and fails in case of a rapid changing condition. As we know that the changing of a PV module's position will take a laborious process. And moreover, whenever you have a cross ties like this will consume a lengthy words. That is the one lengthy words. And now, based upon a puzzle, whatever we have discussed a Sudoku puzzle, the PV modules are arranged in a such a way that based upon the climate condition, the irradiation here is getting changed. Now, what should happen? Again, we need to alter the position of all PV modules. That's why this is called as a one-time configuration method. This will not be worked out for a rapid change in atmospheric condition. Thereby, to the method to work under rapid changing dynamic conditions, we have also proposed a method called electrical array dynamic reconfiguration. That indicates that a system is completely made a automated system. The connections between the PV modules will also be changed regularly based upon the changes observed in the irradiation levels. That is called as a dynamic array reconfiguration. Here is the one. Modules are connected in case of a TCT system and fixed electrical array reconfiguration power comparison system. This is a different connection schemes, series parallel, bridge link, honeycomb, TCT, and these are called as a hybrid connection schemes. Hybrid connection schemes nothing but the combination of different schemes. The power production across the different methods are presented over here. From this, we can observe that the fixed electrical array reconfiguration gives a 375 watts. Compare, it's a higher amount comparing to all other techniques. This is called as a dynamic reconfiguration, what I have mentioned just before. So now, to avoid the lengthy wires and to make a system work dynamically operating, we have connected a power connected switches like this across each row. Thereby, the connections of these switches will be controlled automatically by using of a sensors. Will be providing a signals to these switches. Accordingly, the PV modules, particular PV modules will be get connected like this. Thereby, the power flow will takes place properly as we expect. That is called as a dynamic array reconfiguration. In this one, the major contribution will be taken care by the switching of algorithms. In addition, we may get doubt that the usage of these many switches may lead to the power losses. Obviously, the power losses will be there, but however, these power losses are very, very less comparing to the power loss which we are occurring in case of a partial shading scenario. That is one of the major thing. The according to these switches, the connections between the PV modules will be get transferred like this. This is a complete technique what we have it. The results were presented in a IEEE transaction of sustainable energy. These are the scenarios, different scenarios, creating a shading by practical conditions. The outcome of a PV systems were presented. Here you can observe that this is a 2 by 4 structure. All these results were captured with a prototype on laboratory experiment level physically. So not only the simulation studies, and this is for a 5 by 5 structure. This same different type of a schemes, even up to the 9 by 9 structure also, we have a hardware prototype and tested different algorithms. This is a 9 by 9 PV array dynamic shading. So this particular portion of a PV modules were shaded and the connection of these PV modules were interchanged and observe the scenario. Now you can observe that at time t equal to 1 to 0.1 to 0.2 seconds, the shade is here. So now what is happening? And after that, the shade is moved to the another position. And after that, the shade is reduced and moved the position as well. So these are the three different scenarios with respect to the time domain analysis also we have performed. So these are the results captured with a prototype levels. We can show that even though the partial shading is occurring, the power generating capacity is greatly improved. This is another TCT and AC switching capacitor circuit. So the TCT switching capacitors are nothing but for a TCT system, switching capacitors were connected parallelly, and whenever the shade is occur, the capacitor's connection will be connected and disconnected accordingly to maintain a equal amount of voltage levels across the circuit. Thereby the current carrying capacity of each row will be unique. Moreover, the higher amount of power generation capacity will be increased. So this is another type of a technique what we have it called as a TCT AC hybridization system. And similar to that, the irradiation is created again experimentally under different scenarios. Here, this particular scenario, the modules are receiving 500 and these are receiving 600 and these are receiving 100 watts per meter square. The temperature of individual PV module all is also be changed. So in this particular scenario, the irradiation is changing and the temperature also changing. We may note that because of the increasing of the temperature, the power production may increase, but that's not true. The temperature and irradiation both are different. Whenever the temperature of the PV system is increases, the voltage capacity of a system will be reduces and it moves towards the origin. That's one of the important observation. The curve may come like this. Thereby, the overall power production capacity will be reduces increasing of a temperature. These are the some other cases what we have done and presented the results. And these are the different kind of experimental setups what we have it, as I have worked in a different levels and different institutions as a researcher and also a faculty and postdoctoral researcher. These are the different experimental setups prepared by me, and whatever the results presented here are completely derived by using of these laboratory prototype levels. I'm greatly and proud to share the results achieved by using of developed prototypes. And here this is only a 4 by 4 structure is there. We have also a 9 by 9 structure, and this is a integrated with completely the D space and OpenRT complete system. And this is a kind of nanograde system, and this is a solar emulator, and which will reflect this complete solar PV behavior. The manually we can extract it. And here you can observe that a charging and discharging system which we have developed for the energy management. This is a bidirectional converter which will flows for the charging and discharging, and this is for the boost converter. The system supports for the charging of a system, and these are the sensor circuits and power supply and other. And now comes to the final summary of the discussion. From the discussions, we are able to understand that from the presentation, we gone through the introduction to the PV system, what are the components are there, cost involvement things, and after that the type of a PV system, grid connected with a storage and without storage and standalone system. And after that, the greater effect of a solar PV system is a partial shading. So how we can overcome that? So these things, different techniques were discussed to avoid the partial shading and to improve the efficiency of a solar PV system. These techniques were not only used for the solar PV, a similar kind of the MPPT techniques will also be utilized for the wind turbine systems as well. Recently, we have also initiated to work in the field of a wind turbine systems with the developed algorithms which were produced by utilizing of a solar PV system. And after that, the role of a bypass diode, what it will be doing, advantages and limitations. And these are the partial shading mitigation techniques. These are the generalized ones, circuitry based and MPPT based techniques. And after that, the static reconfiguration, the name itself says that the reconfiguration of a solar PV modules. And dynamic reconfiguration will work even in case of a rapid change of atmospheric condition. That's what we can observe over here. And this is a TCT-SC condition, total cross-tied switched capacitor circuit. The outcome of these works were presented, published in the IEEE Transactions on Sustainable Energy. So that's all from my side. The renewable energy is a future of our planet, and it is in our hands. So this is my research Google Scholar profile. I'm happy to share my research experience and whichever achieved with support of my mentor, supervisor, and my dear students. And with their all support, I reached this level, and it's a proud moment for me to share my experiences with you all. And that's all from my side. Thank you. So here I have provided my email ID. I will be happy to support you all if you have any kind of clarifications, and whoever wish to carry out the research in the field of a solar PV system, I will be happy to collaborate. Thank you.
Whether
Any
my screen is visible, ma'am?
Yes, sir. Yes, sir.
Yes, sir. Yes. Very good evening to one and all gathered here. It's my immense pleasure to present the green electronics and computing. First of all, I sincere thanks to the St. Peter's University management as well as the HOD of EC and the department as well as the coordinator for giving the wonderful opportunity to share related with green electronics and green computing because we are marching towards to the SDG, how it will be supported to the green electronics and computing. For the things I want to share that. So I directly move on to the content. Of course, we know that the evolution of computer right from in the beginning, in earlier of 90s, you can look up in the slide. The first computer is which is occupying the entire room. Then it will be converted into in the relay format or the maybe the things which is called as relay in the entire structures which is called as in like bureau format. Then later of in the 2000 the Pentium computer which is moreover the prolong the world. Then after that it will be shifting to our laptop, the day-to-day affairs we can use the laptop. Now I hope so you are under the mobile phone. The mobile phone or the tablet is uh, act as a computer. So whatever the requirement we need, all the things which is satisfied by even in the mobile phone. So why I am insisting this evolution of computer, because which is highly correlated with our the electronics, especially we switch over to green electronics and green computing. That's why I show the picture of the evolution of computer. So which is highly related with this our context. So that's why I want to fix it as the very first slide. So definitely it will be useful in upcoming days. So everything is behind us in all computer. The computer chips is the major predominant role in every places. Of course, the computer IC or integrated circuit or the chip, which is under the technology of at present in VLSI design, very large scale integration. So of course, many of the electronics professor in the forum, of course, the next the prominent prolongation in the world is VLSI design. Of course, India is marching towards to developing the indigenous ICs. Of course, the Tata is already going to construct the Tata chips. Maybe probably next year end we have to develop our indigenous chip. We never depends upon other countries for pursuing or procuring the chips and all. So any computer, the backbone or the soul of any computer, which is called a chip. So of course, the green electronics is highly correlated with the electronics ICs. So any electronics ICs are the chips, which is we expect the chip must be is speedily operated, and it will be consuming less power. The chip is having very less area. Then of course yield, definitely we will be expect any ICs having with high yield, high efficiency we have to expect. But anyway, the main context in this slide is any chip which is we can expect the high speed and power consumption and the area. So speed, power, area is the backbone for any IC design in the field of semiconductor industry. So even in electronics, if you choose any electronic component, definitely we can expect high speed, definitely it consuming less power, definitely we can expect the occupying the place in very lesser or miniaturized area. Of course we expecting the yield. So these are the preliminary component or the factor behind us or metrics behind us in any IC design or the chip design. So this also, which is related with our the green electronics. That's why the preamble slide I want to quote it in this forum. Then of course everybody, we can see the black color chips having with some pins, 40 pins, 120 pins, or maybe multiples of pin. Of course we never forget that the chip miniaturization, the size is, for an example, this is the diagonal size of one human hair. The probable size is 75 micrometer. But in the IC, inside of that, having with a small channel, the that channel size is probably 180 nanometer. 180 nanometer, this is the 15 years before the technology in the IC. Of course many of the people familiar with VLSI, they know about the feature size. Feature size is nothing but the channel size. The channel size, in the sense the length of the channel. The channel is nothing but the channel formed between source and drain. Of course we are using CMOS. A transistor is enabled inside the VLSI chip, complementary metal oxide semiconductor. So complementary metal oxide semiconductor transistor is used inside the IC, inside the transistor used inside the IC. So in CMOS, having source, drain, and the of course we have here another part which is known that source, drain, and the things the between the channel source and drain, having one channel, the length of the channel is 180 nanometer or 0.18 micrometer. So this is the why I am quoting this slide, which is we are dealing with very miniaturized places, very miniaturized size of working, because VLSI and ultra large scale integration, ULSI, which is very smaller things, in the sense which is micro level dealing, which is role play in the semiconductor industry. So that's why we are dealing with the nano level of technology. At present, of course, we already know that 5 nanometer technology is going on that. This is the example for 180 nanometer. So this technology is 10 years before they are using that. But at present in Intel, they are working under 2 nanometer technology. And last year they are launching 5 nanometer technology of ICs. So these were our for the reference. So then why is prolonged over the entire place? In IC, every places, everywhere, without IC, that functionality is very big question mark. So that's why even in 5G wireless system, they are using 3G and 4G and 5G technology of ICs are there. At present, most of the mobile phone are 4G and the 5G. Having inside that one transceivers are there. They are receiving the 5G signal. They are processing one processor, which is very high speed processor, which is helpful for that to processing the signals that we called as one ICs there inside the mobile phone. Not only the one ICs, multiple number of ICs are there with multiple function. One ICs deals with processing, one is fixing, one is deals with the signal fixation, one is amplification. So many functionalities enabled inside the IC. So that's why even in recent technology, 5G wireless system is they are using the ICs. Then another one recent technology, plastic or organic solar cell. At present earlier stage, the solar implantation in very huge building. But in solar nowadays, the solar cells are there. In even mobile phone cover, they can enable with the solar cell. Even you can see in the invention of paints in our home or the very huge building, they are enabling the paint, that paint which is role play for solar. So many places, there the role play for the solar cell in various place, because it's very powerful renewable energy sources in at present, because the green computing and green energy and green electronics, which is consolidated towards to renewable energy. So that's why even in the solar cell, all the controlling part which is enabled by one electronics. So the solar cell is the best example for renewable energy. So of course, the very recent seminar there, I'm choosing this slide. Then another one is which is called as one of the OLDs. I hope so. Earlier stage conventional LCD, liquid crystal displays that are using that, but it will be consuming more power. But at present stage, in the optical LEDs or maybe OLEDs are the major role play, which is helpful for reducing the power consumption. So which is highly appreciable to minimizing the power losses, minimizing the power losses in this field, because the green electronics and green computing, which is highly supported to the green energy in the world. So green energy in the world, in the sense how to reduce the power consumption in the world. So that's why in the previous slide itself, I quoted in the solar power cell, and previous in the 5G technology, they are using the IC with less consumption of power. Here, earlier stage, they are using LCD display in all the systems, all the places, which is converted into OLED display, which is drastically 80% of power consumption in the computer systems. So these are the very important one. Another one, flexible electronics and display. Earlier they having the portable displays are there. Portable display is nothing but in earlier stage in the home, if you see that having with one CPU, then one monitor, then monitor maybe CRT monitor or cathode ray tube monitor, or then later on that they are using LCD monitor, liquid crystal display monitor, then it will be move on to the LED monitor. Then at present they are OLED monitor or they are using. In upcoming days and in present stage, they are using flexible electronics and display. We can twist the monitor with different direction. Of course, many advertisement and all, you can see that in many mobile phone is foldable mobile phones are there. How it will be possible? They are enabling with flexible electronics and display. So the reason behind us for the flexible electronics, it consuming less power. Then it will be auto rotate, or we can direct, we can twist, or we can rotate with different direction. How it will be possible? Because they are because it having with the portable solar cells and portable LED cells, which is consuming less power and easy to adopt with less voltage. So these are the things behind us for to reduce the power consumption in the system. Then of course, in the paperless campus, there in at present stage in UK, they are already introduced. They are vanishing the newspapers, but they are displaying the newspaper in e-paper. Even examination systems, earlier being the controller of examination of Francis Xavier Engineering College, in many in examination process, most of the Western countries, they are they are eradicating the writing the content in the in the paper, in the answer paper. They are writing the those who are entering to the hall, the student entering to the hall, they are having with one electronic paper the content, the whatever the questions also display in the electronic paper. The students which is answer the question in the electronic paper with the stick pen, then they save that, it will be automatically saved as a PDF, then it will be move on to the evaluator, then immediately they are marking. So drastically per semester around more than 1 lakh of papers they can use in any examination system is completely eradicated due to the electronics paper. So electronic paper, which is highly helpful for to reducing the content in the power consumption and other the energy conservation, which is the major role play. So the electronics paper is one of the new invention happen in many field, in especially in examination, in other paperless campus they are using. So we are all the marching towards to the green energy system. So that's why these are the things are the major role play for the background. So of course in 3D holographic projection, how it will be related to the green energy and green electronics. Earlier stage, if you see that in hospitals, MRI scan or maybe CRT scan, another in film industry they are having the 3D projection. Many systems are there, but at present in the learning environment, all the things are replaced by 3D holography projection, which is called as virtualization. So virtualization process, even in education system, some models, if you want to teach to the student, we can all the content should be prepared in the 3D holography projection, which is highly helpful for to understand the concept with the depthness. So instead of rathering of using the PPT, then 3D holography projection is majorly used in the film industries, especially in medical field, especially in our education field, the role plays high. So in 3D holography projection, one of the IC presence inside the chip, IC's presence inside the system, that will be role play for the holographic presentation. So that's the point I want to share this forum. Then, of course, in microelectronics pills. So these are the why I am insisting that these are the things which is the recent trends in electronics field. How it will be supported to the green electronics. That's the point I want to share that this forum. So that's why in even in microelectronics pills at present, you know that any hospitals they can use microelectronic pill. The pill is nothing but is the capsule, just they are swallowing, and it will be move on to in the body. Then it will be acquiring or capturing the content, presence content in the inside the body. Is there any abnormal cases happen inside that, it will be redirect, or it will be give the data to the outsiders or the doctors. They can easily monitor the showing the progress of the body of any patient. So it will be consuming less power. It's the harmless is also very less. So these are the adventures are there are enabled in the electronics field. Then of course you know that the smart electronics fabrics that we call as e-textile. E-textile, of course, people are wearing shirts, maybe t-shirts, or many cloth are in the day-to-day life. But recent days, the smart electronics fabrics, which is the major role play, is nothing but in the cloth, which is embedded in some electronic system is nothing but electronic track. Some electric track is enabled in the shad. Of course it's act as a Apple watch or some smartwatch. That smartwatch, what are the things they do, what are the things it does, that to monitoring the heartbeat, then the monitoring the human parameters like temperature and the pressures and all. So similarly, which is the e-textile, or which is helpful for the body condition with the different environment, climatic situation. This is the major role play. Many of the European country people, they're already they are using in the smart electronic fabrics as like e-textile. Uh, uh, because one of the ICs also presents are embedded in the cloth. So which is monitoring the body performance and the adapt to the climatic situation also. Then of course another technology which is called as laser communication technology. Here also many satellite more than 3 gigahertz of ICs are used. ICs are used. That ICs are the major role play in the environmental, because the laser communication, which is helpful for high speed of data transfer. So huge data transfer, if you want with the high speed, they can use for the laser communication. So these are the things behind us for the green electronics, especially for the IC invention. Of course, many of the AI based autonomous vehicle, so everything is controlled by one ICs. Even in automobile industries, we know that everything is controlled by IoT, with the support of cloud, but everything is controlled by one ICs. That IC is nothing but is electronics ICs. That IC is under the green electronics ICs. So autonomous vehicle is the best example. In upcoming days, in huge number of autonomous vehicle are there planning for install in the country, so to be installed. But in the IC role is major role play. So if you are converting the green electronics, ICs are the major role play, which is which is supported to the SDG, Sustainable Development Goal. Another one field which is called as embedded system in automobiles, and then how everything in traffic monitoring system, then automobile industries, all the sensors and transducers or smart sensors, everything is integrated in and controlled by the one embedded system, which is called as maybe a different board. Earlier in project panel they are using Raspberry Pi or the Arduino or the Texas boards are they are using. But in advanced level, ARM is the major predominant role in embedded system, in the especially for autonomous vehicle, like automobile industries. All the things are the controlled with the support of the one ICs. So these are the major role play. That another one recent technology which is called as haptic technology. Of course, you know that in website, if you just Google it or the ChatGPT, they're highlighting that haptic technology is upcoming days, which is highly used for the visualization. Visualization is nothing but which is show the in the imaginary part or the 3D or the 4D view. They are using for the haptic technology with the support of one ICs. So whatever the slide I presented in the forum, which is all behind us in the one and only hero is the electronics and the ICs. That's the point I want is that. Then the electronics upcoming days is converted into the spintronics. What do you mean by spintronics? Is nothing but the electron rate of flow of electrons, which is called as current. The electron, the mobility speed, which is double or which is twisted with based on the material. In semiconductor material like silicon, having some electron mobility speed. And then indium and bismuth, which is called third and fifth group element, that which is called as indium bismuth or gallium arsenide. Their electron mobility rate which should be higher. So high speed electronics they are using third and fifth group elements are used. Similarly, in spintronics is nothing but the electron mobility flow and the portions and the speed which is high with the support of support compared with the electronics. So anyway, which is controlled by in the which is controlled by the one ICs. So that's the point I want to think. So now I want to connect the in the previous past around 15 slide, which are the latest technology prevail over the electronic speed. Haptic technology or like maybe holographic, then e-textile, then digital computing or quantum computing, or many examples I quoted in the previous slide, which are controlled by the one IC. That IC, which is the major hero of the entire field, entire domain. So now I want to start with or connect with how the electronics integrated with the STG. Of course, the very theme and the AICT is very graciously addressing the very present expectation in the globe is SDG, Sustainable Development Goal. So even our FDP title, all the things which is addressing towards to SDG, Sustainable Development Goal. So here I want to addressing how the green electronics or the green electronics, of course, green electronics are the chip or which is called as artificial intelligence, how it will be supported to the SDG. That's the point I want to share this slide. Of course, before going to SDG, what are the SDG goals? We know that very preliminary SDG, the very goal number one, the no poverty, and second one is zero hunger, third one is good health and well-being, and fourth quality education, and fifth gender equality, sixth and clean water and sanitaries, and seventh affordable and clean energy, and eighth decent work and economic growth, and ninth industry and innovation, 10th, reduce the inequalities, 11th, sustainable cities and communities, 12th, response of consuming, reduce response of consumption and protection, and third, 13th is climate action, 14 is life below water, because the sea area is the third, 70% is occupied in the globe. Then find life in that things. Then of course we know that the things which is called as peace and justice and, strong institution. Then finally is partnership for the goals. So these are the 17 sustainable goals behind us in the globe. We are marching towards to all the domain in the SDG role. So that's why in our FTP title is for how the electronics and the computing which is supporting to the SDG. So that's why I quoted this slide, because the requirement of IC is huge volume in upcoming days. The reason behind this, the one and only reason is AI is a predominant role to all the field. AI is not only supported to computer and the IT field, which is integrated with all the field. If you see in automobile, the AI is there. If you integrate with civil engineering in smart city field, it is there. If you integrate with the electrical, of course, major role play. If you integrate with the other field, all the biomedical field, which is there. In biotech, medicine, all the field. If you look at any domain in day-to-day life, AI is predominant role. AI's role play is the very drastic and very huge one. But if you see the AI, the very backbone of the AI is the computer. Best example, I want to quote that NVIDIA. NVIDIA is one of the famous IC fabrication company. Of course, you know that NVIDIA is the NVIDIA is the green green developing company. Graphics processor unit is the very semiconductor industries. The graphic processor unit, which is highly developed by the NVIDIA, because the gaming and all, which is the major role play by the NVIDIA. Of course, at present, they are the very highest shares they have in the AI field, especially for DeepSeek or the artificial intelligence, next general intelligence field. There, because in AI, it requires more number of hardware ICs. So electronics role play is high in SDG. We can see one by one how the AI is nothing but the chip which is supported to SDG. The first point is AI for SDG in the first no poverty is the first SDG goal. The mapping of poverty with big data analytics. So how the IC is supported to IC is supported the SDG for the big data analytics. Of course, the big data analytics, everybody know that in the data scientist and data prediction is the major role play in any AI engineer. So in the behind the screen, one IC is there. IC is nothing but more number of hardware ICs are there. So if you properly identify or predict the forecasting and predict based on the big data with the support of IC, which is helpful for to reduce the poverty. That's why the first goal is no poverty. In the world graph, this is the place which is called as Africa. How they are failed in the poverty due to lack of the data analytics is missing. So based on the powerful data analytics, which is helpful for the prediction, we can improve the agriculture area, which is helpful for to reduce the poverty level. Then similarly for zero hunger, the second SDG goal, how to reduce the zero hunger, how to achieve the zero hunger based on the satellite image analytics. We have developed the agro-meteorological monitoring system. What do you mean by agro-meteorological monitoring system? Is nothing but how much amount of or how much area of agriculture field are there, whether the civilization time the agriculture field are converted into civilization part. So we can reduce the deforestation, we can monitor the agriculture field. The people are occupying the agriculture field and they are using their they are developing their building in the agriculture field. Then civilizations are occupying the agriculture field, which are major impact to reduce the agriculture, the paddy development in the sense which is called as the growth of the agriculture is reduced. So that's why in field monitoring, harvesting, picking, weed control, autonomous sowing and shorting. So these are the major role play for to monitoring to reduce the zero hunger. Then third one is good health and well-being. How it will be supported the green electronics to SDG. So of course you everybody know that the preventive healthcare systems are lot of there in medical field. So discover the measures to disease prevention as opposed to disease treatment. So a lot of predictive healthcare systems are there. The doctors are no need to meet the doctors. If the data are sent to the doctor or the predictive analytics or predictive healthcare system analyze the history and data to prevent the future target event. So all the things are possible with the support of AI with support to STG. AI is background role play for the chip electronics. So similarly, for of course being the teachers, the for quality education, earlier stage we went to the college or the schools to learn the things. At present, in the MOOC courses, interactive, massive, open online courses, intelligent tutoring systems, ITS, and machine teaching, challenging based CPL, challenge based learning. So many online tools are there. Of course, we are also being the teacher. We are also using Coursera, Udemy, or EdX, and some of the Kaggles, some assessment tools, Kaggle, HackerRank, then Top Coders, then coding games are many challenging based learning systems are there. How it will be possible? Because with the support of the chip electronics computing. So the quality education is the one of the theme of SDG that will be addressed by our AI in the beginning of the green electronics. Then another one, gender equity. Even in gender in SDG, one of the theme, which is the fifth theme, monitoring and track the gender bias and provide the actionable insight to the decision maker to drive the balanced hiring. Gender inequality is the major threat in any organization. If have women economic empowerment, women
Everyday
economic
பார்க்க
empowerment, that will be a innovative technologies for skill development and training women in
மக்கள் என்ன பண்ணுவாங்க?
vocational trades are the major role play for to addressing the SDG. So SDGs are role play that, because in AI or the green electronics to predict the gender equality,
ஆன்லைன் மீட்டிங் வேற
the
அட்டன்
women
பண்ணீங்கன்னா வீட்ல இருந்து
empowerment,
என்ன
women
என்ன காட்டியமா
economic
மீட்டிங் அட்டன்
empowerment is
பண்ணுவ
lagging,
அப்படின்றாங்க.
that will be addressed immediately. Then the gender bias should be to track the gender bias and to balance the hiring. So these are the things began as for the AI-based SDGs. Then of course, sixth and seventh, of course, smart water monitoring system and management system. The cleanliness of water is one of the theme in SDG that should be addressed by the IoT device and the sensors to monitoring the water level, content, and the harmless pollution, everything which is supported by the supported to SDG. Then affordable and clean energy. Then affordable clean energy is smart renewable energy grids are there. Then early stage, in the power station or power house, power and power power development center, most powers are unutilized or wasted during the transmission time. But at present, having smart renewable energy grids are there. That grids which is helpful for to it's a smart grid which is AI based is AI based grid. It's a IC controlling grids which is helpful for which amount of load is required from the powerhouse, like in home, factories, nuclear power plant, thermal power plant, and hydraulic power plant. Then all the energies are received from the grid. Then based on the load, it will be distributed evenly to the places. So which is helpful for affordable and clean energy. Then which is called as decent work and economic growth. Even AI supported AI keeps the human away from inhuman job, that which is called as what is called inhuman job, which is called as 4D task, that which may be a dangerous or dullness or dirt or dumb. These are the inhuman job. Maybe many mines are there. Many mines, I hope so. In mines, is the very risk happen in the human being. So nowadays they are using robots to monitor and executing the task in the mines. So dangerous and dull and dirt and harmful places and dumb places, we can use the AI based robots are used. Then AI creates a new product and service, resulting in economic growth also. And the statistics is clearly say that nearly an annual average annual work displaced scaled into the size 2016 total labor force, probably 1.2 million and zero point 0.8 million and zero point 0.6 million, nearly 2 million people estimated in 1900 to 1940, worker reabsorption and rate around 0.7 million per year. Then which is the graph which is helpful for non-routine cognitive and routine cognitive and routine manual. The graph which is represent for many of the people, they are under working inhuman job. That is the data is shows that clearly people are working and inhuman job, that will be the risk job. That risk job should be avoided with the support of AI enabled robo, with the support of green electronics. So that's a point I want to share, which is addressing the SDG. Another point I want to share, that industry innovation and infrastructure. Of course, industry 4.0, everybody know that the technology is early stage, 20 years once it will be changed. But at present, which is miniaturized to scale up, scale down to 5 years. Every 5 years, the technology is rapidly changed. The AI plays the instrument role in the fourth industry revolution, of course, industry 4.0. Then that relies on digitization, automation, connectivity and analytics. So all the things which is called as, it's a key enabler for smart factory. For an example, in the picture itself, earlier stage they are using for industry 4 points, they are using assembly line. Then 1969 first programmable logic controller, pick and place robots are there. Then it will be move on to the IoT, Internet of Things enabled machines, the controller and the monitoring system in different place without disturbing the production, without maybe the safety is ensured. Then the process is continuously executing. The production part also should be increases with the support of AI in SDGs. Then AI for SDG reduce the inequalities. Of course, the physically challenged people are there in the society. They are also a human being as like us. Similarly, their comfort to the society, how it will be possible. Robotic assistive system will empower the elderly and physically challenged, leading more equal and inclusive to the society. How it will be possible? The green electronics and the AI, which is helpful for to support the people, physically challenged people or elderly challenged people, to address their problem and support the system. So that's why the green electronics and computing are the major role play. So that's why I cited in this slide. Of course, in SDG, the 11th point is sustainable city and communities. Of course, we can see that smart cities are enabled in the entire India. The cities are enabled with the smart. How it will be smart cities is a multi-modal smart sensor to monitor the different aspect in the city and or the community, and manage the assets and resource effectively. Smart cities to bring the efficiency and bottom line to benefit as well as the environment impact. Why we can't just like as climate smart cities is nothing but to monitor the air pollution, to monitor the traffic, to monitoring the infrastructure in water supply and electricity. Everything is smart. So that's why which is called as sustainable city and communities. So how it will be possible? Not only the civil engineer only is a responsibility, but it is a responsibility for the people as well as the behind the support of the green electronics and the green computing, with enabled by the AI, which is helpful to uphold the SDG theme of 11. Then, of course, the 12th response to consuming and production. The consumption is very important. The monitoring of consumption level and predict the optimal production level to reduce the waste. For an example, in water consumption also, monitoring is important. Water consumption also, monitoring is important. Then maybe you know that even in the petroleum consumption, diesel consumption, energy consumption, all the consumptions are the major role play in the field. So what are the point I want to address? The back behind the screen for the sustainable development goal for green electronics, which is the consumption of monitoring is important. Of course, life below water. I hope so. As the geological in the globe, 70% of the water around in the world. So we are in the 25% of the land only. So we never forget that the what are the things happen in the 70% of the area. So track the illegal fishing activity through pattern recognition, track the marine life migration, underwater exploration using submarine robo. Example in Stanford Ocean One. This is one of the very good scheme. There is the Stanford University. They are completely dedicated their research in the major role play in the underwater, life below water. They're monitoring the climatic situation under the sea. The living things enable inside the water, a monitoring system. So everything track the marine life migrations. So these are the thing which is supported to the people. Then remaining 25, life on land. Life on land, we the people are the life on land. 25% of the area occupied by the people are the human being. Human being in the sense the species are like monitoring the airborne, marine, water pollutant, species health, land use changes, food security, nutrition levels. Then which is called weather related stresses, disease vectors. So these are the very important role play by life on land. Then predict the pollution trend, that which is called population trends. Predict the population trends. uh, Desertifications, trends, epidemic is, even we are completely locked in during the pandemic. So we have a very strong predictive system in life on land, which is support of AI. Definitely is a maximum role play in the things. That's the point I want to address. So what I want to strongly insist in the past 30 slides, I strongly address that electronics is predominantly control the entire domain. We can call this the latest electronic technologies also controlled by the ICs, the electronic green electronics. Then all the sustainable development goals, all the goals should be addressed by the AI, artificial intelligence. Artificial intelligence is not only executed by the software, the very heart of the part is IC. Electronics ICs are the major role play in the artificial intelligence. So how the electronics supported to the AI, that's why I quoted the NVIDIA is the very famous GPU manufacturer. Of course, the graphics processor you need, as well as the chip designs, which is the major role play that. So that's the point I want to address that. So these are the SDG challenges, how the green electronics going to address. So I want to share that the aim of the green electronics, what is mean for us, the aim of the green electronics is nothing but, the aim of the green electronics is to create a path for protection of human and environmental friendly electronics in general, and integration of such electronic circuit. Because if you want to develop a IC, if you want to develop a chip, if you want to develop a electronic circuit which is not harmful to the human or environment, that is the one and only aim for green electronics. Many of the slide I taken from the web or surf in the web. Many of the beautiful contents I received and I consolidate and present in the forum. So that's why a sincere thanks to all the people. There are many of the information I get it from the web, which is really amazing that. So even you can as a participant, I request that you can direct your research or the focus in green electronics and green computing field. Really it's a very impressive one, which is highly supported to SDG also, sustainable development goal also. So that's the point I want. So what will be green electronics? We are going to develop a electronic circuit or the chip or the IC which is not harmful to human and environment. That's the point. Then what are the green electronics? So that's the point I want to share that. What are the green electronics? Electronics that are designed to have low or no adverse impact on the environment are considered to be the green electronics. So for an example, if you develop one electronic circuit, maybe the electronic circuit or the chip, which is the radiation is very high, that the radiation which is harmful to the human, which is impact or which is highly harmful to the tissues of human body, it will be leads to cancer. So that's why the radiation is that which is called SAR, successive absorption rate. Even in a human having some radiation level only bearable. Beyond the radiation from the electronic component, which is affect the small living things like birds, or even in human body, the soft tissues are easily corrupted or damaged with the impact. So green electronics are the major role play in the things. So why green electronics? Of course, this is the part. This is the slide which is represented for huge number of e-waste. For example, e-waste is nothing but electronic which are destined for reuse, resale, or salvage, or recycling or disposal, that we call as e-waste. That electronics, because every field, every domain, without electronics we can't do nothing. So, but the huge volume of e-waste are there, which is entirely disturb the globe. So how it will be reuse or resale or salvage or recycling or disposal? So how it will be possible? I already told that e-waste is not a simple thing. It's harmful to the health effect of e-waste. So this is the picture which is highly alarming or averring about the e-waste. For example, in electronic waste affect the human body because of they contain toxic component including mercury, lead, cadmium, polychromate, and flame retardant, and barium, and the lithium. So these are the chemical composition, because in ICs many of the chemical compositions are present inside the IC during the wire connection, during the formation of base, everything. So what are the harmful to the health effect? Maybe the vomiting sensation, fatigue, and muscular pain, headache, sleeplessness. Then even it's a very dangerous is the lung cancer, abdominal pain, appetite loss, and diarrhea. So these are the very harmful health effect of e-waste. So we can't ignore that, because e-waste is drastically increasing every year, because the electronics utilization is very huge. At present, even in the forum, I'm using laptop, mobiles, and you are also receiving, and maybe you can use maybe your mobile or the electronic gadgets, or maybe laptop or the system or anything. So everything which is under the electronic utilization only. Without electronics, we can't move. Even the people are wearing smartwatch is one of the example for electronics. So every field, even in lamp, early stage only is having lamp with choke and starter, but inside of that having one ICs are there. Without ICs, we can't move anything. So what are the point I want to insist that huge number of evil star every year it will be move on that. So that's why we have to eradicate that. So why lead in electronics? Of course, lead is the very hardcore part of the IC, because 90% of the electronic goods are made up of by lead. Lead is the glue, because it's the glue that bind the semiconductor and the material. So copper is the very copper or the lead, which is the binding the or connecting the things. So what are the point I want to share, that which is called as binding the semiconductor or the material to make them work efficiently. Lead can be easily remolded and refined, and to meet the performance requirement in the cost efficient manner. Maybe what are the natural properties of the lead is having low melting point, high strength, corrosion resistance, long life. Because 90% leads are used in the IC electronics, green electronics. So the 90 percentage of the leads are having the very good property of low melting point, high strength, and corrosion resistance, long life. So we have to reuse this. So that's the point I want to share this forum. Then what are the effect of lead? Because 90 percentage of the part enabled in the ICs, how the effect impact create to the society. Lead is the very toxic mainly because it replaces other metal. Example, maybe a zinc or the calcium and the iron in biochemical reaction. For an example, I want to quote that lead displaces calcium, transmit electrical impulses in the brain, which is diminish your ability to think or recall the information or make you as a very abnormal part. So yet, what are the how it will be toxic? Because lead is the very toxic material. Lead is the toxic mainly because it replaces other metal. We can't directly use the lead in all the because 90% leads are used in the electronics. We have to replace because it will be diminish your ability and thinking and recall the information. How will it be the solution for recycling? Recycling of e-waste is the best method to obtain greener product. How it will be possible? How it will be possible? Recycling of e-waste is the best method to obtain the greener product. It simply remove the hazard into the secondary product that eventually have to disposed. We can, for an example, I want to quote that if maybe you have to use one mobile phone, or maybe you have to use one laptop, or maybe a PC. How to recycle? What are the lead enable in the product that will be removed first? Then plastic materials are removed in the second step. Then some rarest material like gold or some other secondary component of materials are removed. So based on that splitting, and we have to dispose, someone is recycled, some part will be recycled, some part will be reusable, some part will be eradicated or landfilling. So this is the solution for the recycling. Then for an example, incineration and the landfilling is the major two area for to e-waste. One is burning of e-waste. Burning of e-waste is nothing but incineration. Then second one is landfilling. Of course, the picture which is represent clearly burning of e-waste, which is landfilling part. That is the important role play that. Then this is the combined analysis for the percentage of the companies. Of course, you may think about the Wipro, HP, Nokia, Acer, Dell, Samsung, Philips, SCL, Panasonic, Sony, Toshiba, Sharp, then RIM companies. So this is the indicator. This is the indicator. They are marching towards to green. This is the negative part is nothing but more number of e-waste, in the sense more number of e-waste production. These are the company, they are marching now towards to green electronics. How e-cycle, who will be the first to go to the green? This is the race because these are the companies, the giant to control the entire electronics ICs production. As per the November 2022 statistics in the guide to green electronics guide, these are the because at present the RIM company is one of the company, Chinese company, which is produce more number of e-waste than Toshiba, Sharp, and the LG Philips. Then they are moving on to the green electronics. That which is called as their plan to reduce the lead usage inside the electronic component instead of rather than other material. Then
Yes, sir.
yes.
Continue. Okay.
Yes. So the things I want to share that due to the internet issues, then the phase two, which is called as the green computing and the green computing, because the so far we addressing about the what are the latest technology enabled in the electronics industries, and second one is how the SDGs are role play in the electronics, and the what are the pros and cons of the green electronics, and the final part I want to share with the green computing. Of course, many of the computer people are there known about the green computing. Green computing or the green IT refers that to environmental sustainable computing or the IT. So which is called as with minimal and no impact to the society. So or the environment. So that's the point only is very important. So green computing or green IT, how the green computing is working. For example, this the chart, the by chart which is represent for electricity and heat, which is produced 45.90 percentage. But if you move on to the green computing part, PCs and monitor 40%, server 23%, and fixed line telecom, that the connections are 50%, mobile telecom 9%, and LAN and the office telecom, the printer is 6%. So this is the distribution for the computing device. Then earlier stage, which is called as transport, industries, residential, other, because the whole energies are distributed with different places with the different purpose. So the aim of the green community, how we reduce the PC and monitoring 40% to 10%, server 23 to 5%, then telecom we have to drastically reduce with 20% of the energies level, that we called as green, the aim of the green computing. How the computing is harmful environmental, this is a very good strategy. Of course, I hope so you already heard that the cost of the spam. Of course, everybody hearing the spam message in the mail. Around 62 trillion spam message in 2014. In 2014, 62 trillion spam messages are there. Each spam message produce zero point 0.3 grams of carbon dioxide per message. The annual spam energy use 33 terawatts hour in annual spam energy. Then equivalent to the electricity use in 2.4 million homes in every year. You can think about that. We just like this the spam message, just select and delete. Those are the things we are day to day activities we are enabling in the email. But the spam having lot of harm to the environment. We can't think about this is just like one message, because 64 trillion spam message in the year of 2014. Each spam message it's produced zero point 0.3 gram carbon dioxide per message. So overall turnover annual spam energy is 33 terawatts hours, 2.4 million homes everywhere every year. So carbon dioxide dissipated from sleeping device, 1/7 of carbon dioxide emitted by the automobile. These are the statistics or how the computing harm to the environment. Then again increasing in power, cooling and space for the data center. In 2007, $4 billion of electricity. In 2011, 7.4 billion of electricity. In 2011, double the carbon dioxide output in 62 million metric ton. So we can't just say that carbon dioxide is not only burning the things, it will be produced carbon dioxide, because even our computing machine which is hugely produce carbon dioxide. This the statistics is clearly shows that in the year 2011 itself, double the carbon dioxide output for 62 million metric tons due to the power, cooling, and space for data center in labs like server or Amazon cloud server or different cloud server. How the computing harmful environment by electronic appliance, desktop, even our monitor or desktop require 85 watts just in idle. Monitor is off condition, it required 85 watts. Left on 24 hours per day, 1,500 pounds of carbon dioxide per year. A tree, for an example, you can look at the tree, absorb between 3 to 15 pounds of CO2, carbon dioxide each year, up to 500 tree. More than that, we have to produce. Even that's why many companies or many organizations, while if you are living in the room or the cabin, try to switch on the fan, tubes, or monitor. What is the reason behind this? The reason behind this, it always produce some power dissipation and carbon dioxide in air. Then history of green computing. The history of green computing, the term which is called as in 1992, the term green computing was probably coined shortly after the Energy Star program began way out back in 1992. One of the first result of green computing was the sleep mode. Of course, even in mobile phone, we are having sleep mode, wake up mode. In TV, sleep mode, wake up mode, sport mode, many mode. How they are developing that in order to energy minimization. As the concept developed, green computing began to encompass thin client solution, energy cost, accounting, virtualization practice, e-waste. So this is all called many electronic component. This symbol is put it in the all the electronic component, energy star. This is nothing but it consuming less power, it producing less energy, it dissipating less energy. That is the indication. Then, what are the objective behind for the green computing? The main objective of green computing: reduce the climate change, savings, reliability of power, computing, reduce the use of hazardous material. These are the prime objective for green computing. Because this is the major role play for the green computing. Then the objective of green computing, the first objective, climate change. What do you mean by climate change? The first and foremost of conclusive research shows that the carbon dioxide and other emission are causing global climate and environmental damage. So preserving the planet is a valid goal because it aims to preserve the life. Planet like us that support life are very rare. So climate change should be reduced by the green computing. Then objective of the green computing, another one which is called saving. Which one is we are going to saving? Green computing can leads to series of cost saving over time. Reduction in energy cost from the server, cooling and lighting, and are generating the serious saving for many corporations, maximizing the energy efficiency during the product lifetime. So these are the major objective behind us of the green computing. Another one objective which is called reliability of power. How to reliability of the power? As energy demands in the world go up, the energy supply is declined or flat. The energy efficient system helps to ensure the healthy power system. So that's the point I want to share, that these are the things behind us for the green computing. Then computing power consumption also reduced, critical point. Then the usable of power and the cooling system. Then material recycling. Whatever the device we are using in green computing, we are going to material recycling. For example, a part of outdated system may be a salvage and recycled through certain retail and outlet of maybe municipal or private recycling. Many organizations, including some of the manufacturers themselves, are willing to take equipment back to and recycling the component new product. So that kind of material recycling which is supported to the green computing. These are the overall picture or the pathway to green computing. How to execute the green computing? For example, green IT. This is our centric focus. Then green use of IT system, green design of IT system, and green disposal of IT system, and green manufacturing of IT system. So that's why design, manufacture, and use and dispose of electronic component or computer and other associated subsystem with minimal impact on the environment. This is the pathway behind us for the green computing. So first point, how to approach the green computing? First one is visualization. How to visualize? Computer visualization is the process of running two or more logical computer system on one set of physical hardware. We need not to, for example, in earlier stage, maybe a 5 or 10 years back, each computer having one CPU and one monitor and some keyboard and mouse and all there in the basic computer system. At present, if you see any corporate or any computer maybe software company or the hardware company, maximum CPU process is enabled in the cloud or the virtualization. So in order to reduce the hardware utilization of each system, which is minimized. So that's why computer visualization is process running two or more logical. So here in the picture, visualization is nothing but having with application server with the support of Oracle, SQL or print, or maybe storage are there, then email, everything is under, which is increase the efficiency, availability and the security, which is reduce the cost, individual system cost, individual hardware cost, individual energy. So virtualization is the one key component for executing the green computing. That's the point I want to share. Then another point, how to approach the green computing. Power management. What do you mean by power management? Then ACPEI allows to operating system to directly control the power saving underlying the hardware, reducing the cooling requirement, prolong the battery life for portable and the embedded system, reduce the noise, reduce the operating cost of energy and the cooling. So we have to minimizing the noise level, minimizing the cooling requirement, minimizing the operating costs, minimizing the battery life, which is helpful for the power management. The power management is the very important theme behind us in the green computing. Then video cards. Obviously, the video cards are the major role play. That is nothing but GPU, graphic processing unit, maybe game programming and all. A fast GPU, for example, a fast GPU, largest power consumer. No video card in the system, use the shared terminal or desk sharing software if display the record, or use motherboard video output are typically low 3D performance or low power, or reuse an older video card that use the little power. Many do not record the heat sinks or the fans. So try to avoid the video cards enabled in the system. If required, we have to use the shared terminal desktop sharing the software, or motherboard video output, or reuse the older video card. These are the suggestive methodology or the approach behind us for the green computing in the aspect of video card utilization. Another part which is called telecommuting devices. Commuting also major role play for the green computing. Reduction of greenhouse gases like CO2 emission related to travel, or increase the profit margin, increase the worker satisfaction, which is helpful for telecommuting devices are the major role play. So that's a point I want to share that in the forum. The reduction of greenhouse gas emission through telecommuting. For example, recently implementing of green computing search. If you type it in the Google, Blackly is one of the forum or one of the web browser or website which is helpful for reducing the power consumption based search engine. Then recent implementation of green computing. How it will be executed? Recent implementation of green computing, which is called the computer name, which is called Zonbu computer. That Zonbu computer having what are the features is that energy efficient PC consuming just one third of the power typically light bulb. The device runs the Linux operating system using the 1.0 GHz processor and 512 MB RAM. So which is fit the PC design fitting with the standard PC with the too bulky noisier power hungry. Fit the PC draw the 5 watts consuming a day, less power than traditional PC consuming in 1 hour. So what the point I want to address in this slide, having Zombo is the computer name, having with the energy efficient PC, one third of the power use 1.0 GHz processor, 512 MB RAM. There it will be developed and fit in the PC, which is less power hungry. Then recent implementation of green computing in Sunray Thin Client. This is one of the company. They are introducing one solution for green computing. Thin client like a Sunray consuming wireless electricity conversion desktop, consuming 4 to 8 watts of power because most of the heavy computing is performed as a server suited for cost sensitive and healthcare devices are the major role play in the recent implementations of the like which is called green computing. Then how to improve the execute the green computing to use the low power desktop. I obviously insisted that low power desktop is or low power laptop computer, maybe a 40 to 90 watts rather than highly 300 watts of desktop should be avoided. So kindly utilize 40 to 90 watts of low power desktop may be used for to executing green computing and recycling the scheme. So hardware from manufacturer, hardware recycling scheme, recycling that old computer to sending into the landfill. Try to avoid replace your CRT screen with the LCD screen, which are the helpful for the green computing. Finally, I want to quote that how the power consumption in an average laptop. I hope so. This presentation also maybe you were here through your laptop or cell phone. You can see that this pie chart, which is highly represent for display due to maximum power consumption in the laptop. Display or the panel or the inverter 33 percentage, which is power consumption by the display device. Fan which is occupying, coolant is occupying 2%, LAN is in your laptop having LAN is there 2%, DVD 2%, Intel input output hub 3%, clock we are having the clock ICs enabled inside the laptop 3-5%, hard drive 8%, graphics card 8%, miscellaneous 8%, Intel memory controller hub 9%, power supply 10%, CPU only for 10%. The power hunger or power utilizer major component is nothing but your display panel or inverter or the display 33%. So we more concentrate to reduce the display. So maybe the challenges. So simple task we can do it. Turn your computer and monitor when you are not using it. These are the suggestive methodology and the practice to executing the green computing, which is highly supported to SDG development goal, that which is called a sustainable development goal. So already we know that turn your computer monitoring off when you are not using it. Enable the hibernation using power management setting. You kindly use standby, does not save much power. Use the Linux, maybe such as Ubuntu, which require less resource many other than operating system. If you use other operating system, be consuming more power. Maybe a Linux or Ubuntu, which is consuming less power. That's the point I want to address. Then another one point I want to share that in this forum, which is called as for approach of green computing, because display is occupying more places. Displaying is occupying more power. So how to reduce the power? More power in it. LCD display use CCF bulb or LED bulb, or maybe 3 times less when active, at 100 times less energy in sleep mode. LCD up to 66 percentage of more energy. LCD use smaller size, 21 inch CRT typically use more than 120 watts. So try to avoid that. Then algorithmic also efficiency. If you are there, these are the physical things. Earlier stage we discuss about the physical things. Even if you are using algorithmic efficiency, optimum code, yeah, the efficiency of the algorithm is used to describe the property of algorithm related to how much resources in consume. Algorithm are the base of any computing system or electronic device. To chip to certain algorithm which is complete the function. Even though these chips are small, they use lot of power. So algorithmic efficiency is the major approach in the green computing. For example, I want to closing the presentation with step by step, which is Apple is now they are move on to steps by Apple for green computing. What are the steps initiated by the Apple? MacBook keyboard are made from one single piece of aluminum. This is one of the initiative taken by the Apple. MacBook Pro notebook have long-lasting batteries where their normal notebook 3 batteries. This is second initiative. Then MacBook, that will be Apple MacBook, will only use one throughout its lifetime. This is the initiative. Then what are the step initiated by the Dell towards to green computing? Their free worldwide product recycling program allows to properly dispose their product safely. Their plant a tree for me project can offset of consumer carbon emission for the only $3. These are the initiative steps taken by the Dell towards to green computing. So finally, I conclude that what are the advantages of green computing? Energy saving, environmental friendly, cost effective, pay over time, save more money per year, can give you a tax write-off. What are the disadvantages of green computing? High startup cost. Of course, the awareness and all, we record high startup cost. Need not ready to available, still experimental stage. Sacrifice the performance for battery life, not for everyone. So these are the some challenges in front of us for the executing the green computing. What are the future of human green computing? The plan towards to green IT should include new electronic product and service with the optimum efficiency, all possible option to energy efficiency. That is energy enterprise wise. Enterprise-wise companies are launching eco-friendly component in computer, eco-friendly sustainable component will become the norms rather than the exception in the future. As a conclusion, I want to share that so far consumer have not cared about the ecological impact buying the computer. They have carried only about the speed and the price. It's honestly true, including myself. But of course, the green computing can lead to lot of energy saving, reduction of emission in carbon dioxide and CFC, chlorofluorocarbon, because which is leads to environment protection. It also leads to serious cost saving over time. The features of green computer are computing towards to like efficiency, manageable material, and recyclable server model, self-product, other trends. So I conclude that as a green electronics and green computing, which is helpful for sustainable development goal, which is reducing the which is reduced to harmful to the environment, to save the planet with the support of green electronics and green computing. So I sincere thanks to the AICT to supporting the ATAL transfer, ATAL scheme to the FTP. Of course, most of the things you are familiar with that. Anyway, being a teacher, we are the ultimate role model to our student. Try to execute the green electronics and green computing. Day to day we practice these things which is indirectly we support to the environment and support to the globe. They are fixing the SDG, sustainable development. We are also the one of the contributor to SDG. So I sincere thanks to the coordinator and other people to making the opportunity to sharing the views to the participant, which is I believe that I hope so. It's definitely fruitful to you for carrying the content to your research work. Thank you, Professor. Thank you for the opportunity.
Thank you, sir. Thank you very much for your session on green electronics and computing, which
Thank you.
gives us a deeper understanding on designing and manufacturing electronic devices that uses eco-friendly materials and reduce the usage of hazardous substances like lead. Thank you so much, sir. And
Thank